Now, let us study perpendicular bisector theorem. Part 1. If a point is on the perpendicular bisector of a given segment, then it is equidistant from the end points of that segment. See the figures alongside. Proof of Part 1. It is given that 1. Line L is perpendicular bisector of segment AB. 2. Point P is on the line L. 3. Point C is the midpoint of segment AB. We have to prove that PA is equal to PB. Let us see the steps of the proof. It is given that the point P is on line L. There are two possibilities regarding point P. 1. It may be on segment AB, that is, point P is in between A and B. Or 2. It may not be on segment AB. Case 1. It is given that suppose point P is on segment AB, that is, point P is in between A and B, and point P is on line L. Therefore, line L intersects segment AB in point P. But it is also given that line L is the perpendicular bisector of segment AB. Therefore, line L intersects segment AB at its midpoint C. That is, line L intersects segment AB at points P and C. It is possible only if P is equal to C. That is, P is the midpoint of segment AB. Therefore, PA is equal to PB. Case 2. Suppose point P is not on segment AB, that is, P is not equal to C. Therefore, points P, A and B are non-collinear points. Therefore, it is given that these 3 points form a triangle where C is the midpoint of its side AB. In triangle PAC and triangle PBC, it is also given that as point C is the midpoint, segment AC is congruent to segment BC, since it is given that each angle is of 90 degrees. Angle PCA is congruent to angle PCB. As they are the common sides, segment PC is congruent to segment PC. Therefore, according to the side angle side test, triangle PAC is congruent to triangle PBC. Therefore, segment PA is congruent to segment PB, since they are corresponding sides of congruent triangles. That is, the point P is equilateral from the end points of the segment AB. Part 2. If a point is equidistant from the given 2 points, then it lies on the perpendicular bisector of the segment joining the points. Now, coming to the theorem. If two sides of the triangle are not congruent, then the angle opposite to the greater side is greater. See the figure alongside. It is given that in triangle PQR, PR is greater than PQ. We have to prove that angle PQR is greater than angle PRQ. Construction. Let us take point P on segment PR such that PQ is equal to PT and draw segment QT. Let us see the steps of the proof. According to the construction, in triangle PQT, PQ is equal to PT. Therefore, according to the isosceles triangle theorem, angle PQT is equal to angle PTQ. Let us mark it as statement 1. Now, angle PTQ is the exterior angle of triangle QTR. Therefore, according to the exterior angle theorem, angle PTQ is greater than angle TRQ. Let us mark it as statement 2. Therefore, from statement 1, we can say that angle PQT is greater than angle TRQ. That is, angle PQT is greater than angle PRQ, since point T is in between P and R. Let us mark it as statement 3. Now, point T is in the interior of angle PQR. Therefore, angle PQR is greater than angle PQT. Let us mark it as statement 4. Therefore, from statements 3 and 4, we can say that angle PQR is greater than angle PRQ. Hence, in a triangle, angle opposite to greater side is greater. Let us solve some questions from exercise 3.3. Question 1. Perpendicular bisectors of two sides of the triangle intersect each other at a point on the third side. Then show that the triangle is right-angled triangle. Solution. It is given that, let us name the figure as triangle ABC, in which midpoints of sides AB and BC are E and F respectively. EG and FG are perpendicular bisectors of sides AB and BC meeting at point G, which lies on side AC. We have to prove that angle B is equal to 90 degrees. Let us join points B and G. Let us see the steps of the proof. In triangle AEG and triangle BEG, side AE is equal to side BE. Angle AEG is equal to angle GEB is equal to 90 degrees. Side EG is congruent to side EG, since it is the common side. So by SAS congruence test, triangle AEG is congruent to triangle BEG. So, side AG is equal to side BG, since they are corresponding sides of congruent triangles. It means triangle ABG is an isosceles triangle by isosceles triangle theorem. So, let angle EAG is equal to angle EBG is equal to, say, X. Let us consider it as statement 1. Similarly, in triangle BFG and triangle CFG, side BF is equal to side CF. Angle BFG is equal to angle CFG is equal to 90 degrees. Side FG is common. So, by SAS congruence test, triangle BFG is congruent to triangle CFG. So, side BG is equal to side CG, since they are corresponding sides of congruent triangles. So, triangle BCG is an isosceles triangle. By isosceles triangle theorem, let angle FBG is equal to angle FCG is equal to, say, y. Let us consider it as statement 2. Now, in triangle ABC, angle EAG plus angle EBG plus angle FBG plus angle FCG is equal to 180 degree. From statements 1 and 2, we have x plus y is equal to 180 degree. Therefore, 2 into x plus 2 into y is equal to 180 degree. Therefore, x plus y is equal to 90 degree. Therefore, angle EBG plus angle FBG is equal to 90 degree. Therefore, angle ABC is equal to 90 degree. Thus, triangle ABC is a right-angled triangle. Hence, proved. Question 2. In triangle ABC, the perpendicular bisectors of side AB and AC intersect each other at point P. Show that the perpendicular bisector of side CB also passes through point P. See the figure alongside. It is given that in triangle ABC, the perpendicular bisectors of side AB and AC intersect each other at point P. We have to prove that perpendicular bisector of side CB also passes through point P. Let us join points PA, PB and PC as shown in the figure. Let us see the steps of the proof. It is given that point P lies on the perpendicular bisector of segment AB. Therefore, PA is equal to PB. According to the perpendicular bisector theorem, that is, if a point is equidistant from the given 2 points, then it lies on the perpendicular bisector of the segment joining the points. Let us mark it as statement 1. Also, it is given that point P lies on the perpendicular bisector of segment AC. Therefore, PA is equal to PC, according to the perpendicular bisector theorem. Let us mark it as statement 2. Therefore, from statements 1 and 2, we can say that PB is equal to PC. Therefore, point P is equidistant from the endpoints of segment BC. Therefore, point P lies on the perpendicular bisector of segment BC, according to the perpendicular bisector theorem. Hence, proved. Question 3. The point P is in the interior of triangle ABC such that ray BP is the angle bisector of angle ABC, but ray CP is not an angle bisector of angle ACB. Then prove that ray AP is not an angle bisector of angle BAC. Solution. See the figure alongside. It is given that the point P lies in the interior of triangle ABC such that ray BP is the angle bisector of angle ABC, but ray CP is not an angle bisector of angle ACB. We have to prove that ray AP is not an angle bisector of angle BAC. Draw segments PM perpendicular to side AB. Draw segments PN perpendicular to side BC. Draw segments PQ perpendicular to side AC. Let us see the steps of the proof. It is given that point P lies on the angle bisector of angle ABC. Therefore, PM is equal to PN. according to angle bisector theorem. It is given that point P does not lie on the angle bisector of angle ACB. PN is not equal to PQ. PM is not equal to PQ. Therefore, ray AP is not the angle bisector of angle BAC. Hence proved. Question 6. Construct any acute angled triangle PQR. Find a point in its interior which is equidistant from points P, Q and R. Use compass. Justify your construction. Solution. Let us see the steps of construction. Construct any acute angled triangle PQR. Construct line L perpendicular bisector of side PQ. Construct line M perpendicular bisector of side PR. Let the perpendicular bisector L and M meet at inside the triangle PQR at a point, say O. The point O is called orthocenter of the triangle. Point O lies on the line L1. Therefore, OP is congruent to OQ according to the perpendicular bisector theorem. Let us mark it as statement 1. 2. Point O lies on the line M3. Therefore, OQ is congruent to OR according to the perpendicular bisector theorem. Let us mark it as statement 2. 4. Thus, from statements 1 and 2, we have OP is congruent to OQ is congruent to OR. Therefore, point O is equidistant from the point PQR.